Hi everybody. So last lesson we talked about the law of sines, and now, not surprisingly, yes, there is a law of cosines, and it exists to kind of do the same thing that the law of sines does, in the sense that if we have any triangle, if we know three pieces of information, or three of the six pieces of information, that is the three sides and the three angles. If we know three pieces of information, we should be able to get the other three. Okay, and the law of sines, we're going to see that that works out about two important cases. So the law of sines, it looks like there are three parts to it, but it's really the same thing. Basically, so if you have a regular triangle here, just says if you have an angle and you consider the side opposite the angle, the square of the side is going to be the sum of the squares of the other two sides minus the product of 2 times the length of the other two sides times the cosine of the angle. Okay, that seems like a lot, but it's not too bad once you get to do this a few times. So when you look at this, it almost looks like this is like a generalization of the Pythagorean theorem, and it is, because if the angle is 90 degrees, then the cosine of 90 degrees is 0, and all of these terms just go. This term just goes away. So if this was a right triangle, then we just have c squared is equal to a squared plus b squared, and that's the Pythagorean theorem. But now we have something that actually you can use for other angles as well. So what I'm going to do is I'm going to prove this, even though we won't have to duplicate this on the test. I want to prove it just to show you that we're not pulling this out of thin air. It really just comes from right triangle trigonometry. Okay, so why is this true? So what I'm going to do, I'm just going to prove one of these equations, and the other two is similar. It's just you just have to take this triangle and put it on flat, depending on what side what side you're trying to work with. So here we have so it's sitting on side C, and we break this. We can break it in this case because the angles are all less than 90 degrees. We have a triangle like this, so we can split this into two right triangles, and we'll call this altitude H, and we'll call this side C1 and this one C2, and obviously C1 plus C2 is equal to C. We know from right triangle trigonometry that C1, that is B is the hypotenuse of this right triangle, so C1 divided by B is equal to the cosine of alpha, or that's the same thing as saying that C1 is equal to B cosine alpha. And similarly, this is the opposite side, so H over B is the sine, and so H is equal to B sine of alpha. All right. So now we use the Pythagorean theorem for this triangle, the second triangle here, and obviously we know that this side squared plus this side squared equals this side squared. So we have a squared equals h squared plus c2 squared. Okay. Now we just make these substitutions. We replace h with b sine alpha, and we know that c2, of course, can be written as c minus c1, and c1 can be replaced with b cosine alpha. So that's what we have here. And then, and by the way, this should be squared. Shame on me. And then we can multiply this out. This is just b squared sine squared of alpha. And then if we multiply this out, we get c squared minus 2bc cosine alpha plus b squared cosine squared alpha. We can take this term and this term together and factor out the b squared. And we want to do that because we know from the fundamental identity that sine squared of anything plus cosine squared of it, that same thing, is going to be 1. So this just becomes b squared plus c squared minus 2bc cosine alpha. Okay, so that's how we get the that's what a squared is. Okay, so that's how we get this this version. And then to get the other two, you could just take this triangle, turn this triangle around so that this side is flat. And then when you do that, then do it again so that this side would be flat. And that's how you get the other two equations. Now there might be a case where you end up with a triangle where that looks like this, where you can't really quite divide it in two. So what you can do is you can extend it to a right triangle by just drawing the altitude like this. And now you have a right triangle here where the hypotenuse is B and the opposite is H, and the adjacent side is C plus the new distance we'll call C3. And then we use the, well actually, and you can see we actually have two right triangles here. One here and one here. And then we can use the Pythagorean theorem on this smaller right triangle. You get a squared equals h squared plus c3 squared. And then we do a little trick of adding and subtracting c here. And then we can replace h. H of course is b sine alpha, because b is the hypotenuse of this bigger right triangle. So h is b sine alpha, and c C plus C3 is going to be the adjacent side of this big triangle. So C plus C3 is B times the cosine of alpha. So that's how we get this. So this C plus C3 is now B cosine alpha. And so then if we expand everything out, we get B squared sine squared plus B squared cosine squared minus 2CB, or 2BC cosine alpha plus C squared. And once again, we can collect the sine squared plus cosine squared. That's 1. So this is going to be b squared plus c squared minus 2bc cosine alpha. Okay, and once again, that's a squared. Okay, so that's how we do this. You're not going to have to reproduce this on the test, but I wanted to show you how it's gone. And isn't it nice that we're doing this online, and didn't have to write this on a blackboard, and you copy it down and waste 10 minutes like that. Okay, so, but now what thing you will be responsible for is knowing how to do these next few examples. So let's look at the two cases where where you use the law of cosines is when you have a situation like this where you're given two sides and the angle between them. Or it might be that you're given all three sides. Then you go ahead and use the law of cosines. Okay. So how do we do this? Well, let's do this one first. Okay. So first of all, let's call this side, the side opposite this angle of 50 degrees. Let's call its length x. And then by the law of cosines, it says that x squared is going to be 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of 50 degrees. Okay. Okay, well that's not too bad, and we can just use this on our calculator. Make sure your calculator's in degrees mode, and you get x squared is 14.7163. In these intermediate calculations, it's kind of a good idea just to take as many digits as you can, just to be more accurate. And then you take, so x is just going to be the square root of this number, okay, which is approximately 3.8. Okay, so that's what x is. Okay, if you wanted to be more accurate, you could. But. Okay, so that's what this angle is, or this side. Now let's see what, say if we wanted to find these other two angles here, what would they be? Let's call this gamma, and let's call this beta. And now let's find out what gamma is. Okay, so we now know all three sides of the triangle, so that's not, so we'll just use the law of cosines again. So in this case, our angle in question is gamma. The side opposite that, it has length 5, so 5 squared is equal to 3 squared plus x squared minus 2 times 3 times x times cosine of gamma. Okay. Well, we all know what we know that x is 3.8. Okay, so okay. And then you just go ahead and simplify, do a little algebra, take these two other things over here, or what you can do when everything is said and done, you can subtract these two numbers over here, and then you'll get 5 squared minus 3 squared minus 3.8 squared. Okay, but then you'll have negative 2 times 3 times 3.8 times cosine. So we can divide by negative 2 times 3 times 3.8. And that gives you the cosine of gamma. All right. If you're not sure about this, you can do it. You can do this intermediate step, which you have 5 squared minus 3 squared minus 3.8 squared equals negative 2 times 3 times 3.8 cosine of gamma. Okay. But then you just divide both sides by this, and you get this. And on your calculator, this is the cosine of gamma turns out to be negative 0.0684. Okay, and now you can just take the inverse cosine. And when we do this, we only have to worry about one possible value, because the inverse cosine, there's only one angle. The cosine of anything has to be between 0 degrees and 180 degrees. And our angles are in that range. So that as opposed to the sine, taking inverse sine, when you take the inverse cosine of this, we don't have to worry about being any other values we haven't looked at. So the inverse cosine of negative 0.0684 turns out to be 93.9 degrees. Okay, so that is gamma. And we could, that kind of sees, it looks like this is going to be close to 90 degrees anyway. And then to find the other angle, we just have to use the fact that the sum of the angles adds to 180. So beta is going to be 180 minus 93.9 minus 50. Okay, which is, so beta is going to be 36.1 degrees. Okay, so that's how we solve this one. Now, for the other case, when we have all three sides and we don't know any of the angles, we kind of have to use the law of cosines, and we can just use the law of cosines as many times as we want, maybe even 3 times, even though we really won't have to use it 3 times. So just pick one. Let's label our angles. Let's say this is alpha, gamma, and beta again. And we know that, well, basically what we're going to be doing is, in the last part of the example we just did, we're going to find the cosine of the angle and then take the inverse cosine to get the angle. So let's first do this one. We have 5 squared is equal to 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of alpha. Alright, so then the cosine of alpha turns out to be 5 squared minus 6 squared minus 8 squared over negative 2 times 6 times 8. And this is 0.78125. Okay, so alpha is going to be the inverse cosine of that. Okay, which is 38.6 degrees. Okay, so that's alpha. Okay. You can do the same thing for beta. If the side opposite beta has length 6, so we get 6 squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of beta. And doing this, we get that the cosine of beta, well, it'll be 6 squared minus 5 squared minus 8 squared over negative 2 times 5 times 8. And this is equal to 0.6625. So beta is going to be the inverse cosine of 0.6625, which is, according to our calculator, 48.5 degrees. So that's beta. Okay. And then gamma is, we have these two angles, so now gamma is easy. We just take gamma to be 180 minus 38.6 minus 48.5, and that turns out to be 92.9 degrees. Okay, so really you just have to use the law of cosines a couple times. So in some ways it's a lot easier than using sines. You don't have to break it up into all these cases and worry about no solutions or two solutions. Okay, so just have to do a little bit of algebra. Not too bad when you're working a calculator. So we'll come back on the next video. We'll do a couple quote unquote real life examples.